Hello friends, welcome to my channel. So in this video, I am going to discuss the energy stored in a wire during the extension. Okay, and I am going to find the energy density. So what is the formula for energy density? Is that work done per unit volume. It means change in volume. So it means basically I am going to find the energy density when my wire is extended. Okay. So suppose I am taking a wire and the length of this wire is L. If we put some load, what happened? Its length may change. Suppose this is mg, its length is changes. So I can assume this is small l. So that thing already we discussed in our string chapter. So this is my original length and this is the change in length after putting some load. Now suppose this is A, I can assume this is B, I can take small parts C and this is B. So if it is X, then I can assume this is the dx. So my aim is to find the energy density. So basically we know that, and we have already studied that if anything related to the change in length, then we are going to use the Young's modulus. So what is Young's modulus? Y equal to normal stress. This is the normal stress divided by longitudinal strain. So what is the longitudinal change? Small l by capital L. Small l is the change in length and L is the original length. Okay. So this is the formula for Young's modulus. Now I applied this formula in this cases. Okay. So this is my Y, F is there, A is the area, and this L is the that small x. Okay. By capital L. So here I can write this F is a F dash. So F dash equal to, so I can write F dash by A and capital L by x. So F dash equal to, I am getting Y A x by L. So this F dash is the restoring force. So what is restoring force? Already we discussed that in the restoring force. Restoring force basically, if anything changes its size, then some force tries to oppose that change. Okay, so and that force we can say this is the restoring force, because it means a force tries to oppose the changes, then we can say this is the restoring force. So in case of elasticity, the restoring force there, because the elastic nature is that it tries to again regain its original shape and original size. So what is the restoring force? Restoring force means that if anything changes, if its volume, its sizes changes, then one force that tries to oppose that changes, then we can say this is the restoring force. So this is the formula for the restoring force, and this is the Young's modulus. Now you see our aim is to find the energy density, and this is the work done and this is the volume. So now what is the work done? So small, I can assume dW. dW is a small work done in that system. So we know that dW equal to F dx. Understood? So what is F? F dash in that case Y A x L into dx. So this is my dW. Okay. So now what is total work done? Total work done, I can assume this is W. So integration 0 to W dW. Then I can write it is 0 to L, because this is the L, 0 to L, and Y A x L dx. I think up to this you understood. Now next, so now if I integrate this thing, so what I will get? So W equal to Y A L integration 0 to L x dx. So I can write it just like this, Y A L. So it's x square by 2 0 to L. So if I put this value Y A L, so L square by 2. So it means my W equal to Y A L square by 2. Okay, so I can write it just like this: W equal to half Y A L by L into L. Okay, so you see, we already write that our f dash equal to Y A X into capital X. Okay, so this f dash is the restoring force, so this is also same now Y A L divided by L. So I can say this is the okay, I can write it here: Y A L by L equal to, this is the deforming force, or you can say the applied force. Okay, so this is my restoring force and this is my the applied force or deforming force. So now I can write half into, this is F, so half into F into L. Okay, so this is my work done. So what is the work done? Work done is the half into F into L. So now our aim is to find the energy density. So energy density. So what is the formula for energy density? We know that work done per unit volume or change in volume. So what is the work done in that case? Work done is half into F into L. Okay, and what is the volume? Volume, we can write it like this. I can write like this. Volume is area into length. Okay, so you see, this is half F by A into small l by capital L. So what is F by A? So we know that F by A is the stress and this is strain. So ultimately I can write our energy density E equal to half into stress into strain. So this is my formula for energy density. Okay, you see, energy density means work done per change in volume. So what is the formula for work done that we calculated? That work done W equal to half L into L. So I can write half F into L. And what is the volume? Volume is the area into length. Okay, so I can simplify the half F by A. We know that F by A means stress and change in length by original length is the strain. So what is my energy density? Energy density is the half into stress into strain. So this is the formula for energy density when it is extension, when it is an extended case. Okay, so thanks for watching. Please like and subscribe my channel to get the more updates. Thank you.